So I will write a program to give demonstration for linked hash map. For linked hash map, I should first of all import java.util. I will take all the classes from there. Then inside the main method, I will create an object of linked hash map. And keys, I will take them of type integer, and values, I will take them of type string. So linked hash map, I have taken the reference name. I have taken the capacity as 5. So the capacity of hash map is 5. So this hash map will be taking integer keys and string as the values. So I have created an object. Now let us insert few values. Linked hash map dot put. I will put the value 1 and the key is 1 and the value is A. Like that I will insert few more. I have inserted 6 keys and with their values. So I have entered 6 entries in linked hash map. Let us print them. Linked hash map. I can use an iterator or even I can use a for each loop and write lambda expression which will take a key and the value. So I will print both. So this lambda expression system.out.println, I will print key, then space, then value. So this will print keys and the values. Let us run. Yes, it has inserted these values and it is showing them in the same order in which I have inserted. Same order. But one thing to observe, I gave the size as 5, initial size as 5. That is just initial size. It is not a limited size. Initially 5, and if the values are increasing, you go on increasing the size of the hash table. So it is allowing me to insert more values also. Now let us insert one more value. After this, I will insert linked hash map dot put 9. Okay. Then it is I. Then again linked hash map dot put. Now I will insert 8. So first 9, then 8. Okay. So this is H, alphabetical order. So this is the 8th alphabet. So 1, 2, 3, 4, 5, 6, 9 and 8. So they should come in the same order. Okay. They should not be in sorted order or their order should not be changed. Sorry. 1, 2, 3, 4, 5, 6, 9, 8. Yes, they are appearing in the same order. So order of the keys is maintained. Yes, that's what I have explained you. It will maintain the order. Now next thing I will show you. For that I will remove few keys. There are too many keys here. I will remove them. Okay. Let us take only 5 keys. Now linked hash map dot get. I will access one of the key, that is 2. Okay. Then linked hash map, I will access a key that is 5. Sorry. Get 5. I will get the key. I'll give the key 5, I'll get the value actually. So if you want to take the value, then you can take it in a string type of variable, string type of reference. So you can take the string value. Given the key, we get the value. Alright. So I am getting this one 2. So I'll get B, and the second one is 5. I will get E. So I'm reading them. So when I am accessing these keys and the values, will the order change or it remains 1, 2, 3, 4, 5 only? Let us check first. It is remaining 1, 2, 3, 4, 5 only. Because after accessing I am printing them here. So the order is same. Now I will change something and show you here. See, there is one constructor where you can mention initial capacity and the second is loading factor. So loading factor is 0.75 by default, right? By default it is 0.75. So let us take 0.75 only, but you have to mention. Now next parameter is whether you want them to be in the order of access. If yes, then mention is true. So if you want to change the order, not based on insertion, based on access, then mention this as true. So now the keys will be shown in the order of their access. So the first key shown will be least recently used. So which is most recently used just now? Recently used is 5. Then before that was 2. And 3, 4, 1, 3, 4 we never accessed. So I will do one thing. I will access one more, that is 1 also I will access. So most recently accessed one is 1, then 5, then 2. So 1, 5, 2. Before that 3 and 4 are never accessed. Let us run this and check and see what it will display now. See, 3 was never accessed, least recently accessed, 4 was least recently accessed, then 2 was accessed, then 5, then most recently accessed one is 5. So they are not shown in the order of their insertion, they are shown in the order of their access. So just a constructor will define which type of ordering you want. So in this constructor, you must also mention loading factor. If you want to change the loading factor, you can change it. So depending on the keys that you are inserting, the size of the hash table will be becoming larger. Okay. Now don't ask me how this hash function will work. So actually the idea of hash function that I gave you was just for understanding. Java is using its own hash function, so it has its own way of arranging the keys. So if you have to study further if you want to understand that. So for basic understanding, I have used hash table of size 10 and hash function as xmod 10. If the hash table is increasing, obviously hash function should also change. Let us come back. Now, I want to limit the size. I don't want the values to be inserted more than 5. Like this, if I am inserting one more value like LinkedHashMap dot put 6, I want to insert a next value, that is f. Okay, I want to insert one more value, so it should not allow. It will allow me to insert. It will allow me, right? 6 is insert shown at the last because it is recently inserted, so most recently accessed. Okay, most recently accessed. Insertion itself, we are accessing it, right, while inserting. So most recently accesses at the last and least recently accesses in the beginning. It is allowing me to insert 6. But suppose you want to limit the size to 5 only, not more than 5 keys, then you have to override one of the method inside this LinkedHashMap class. So for overriding, we can do it using anonymous class, inner class here itself. So I will override the method. So let us see what is the method we have to override. One of the method is protected. It must be protected only, and it returns boolean. Okay, and the method name is remove eldest entry. This is the method I must override, and this method should return true if the size is greater than 5. So I will write on column method size. This method belongs to linked hash map. If it is greater than 5, then return true. So if it is, this method should return true, saying that whether you want the eldest entry to be removed. So who is eldest? If you are following ordering based on insertion, then the first inserted one is eldest. And if you are following the ordering based on access, then the least recently used is eldest, because it was not accessed from long time, so it should be removed. So this method is internally called by a linked hash map to know whether entry should be removed or not. So if you say if size is greater than 5, then start removing. Let us see now what happens when I am inserting 6. So who should go away? Least recently used. So who is least recently used? Already we have seen that this 3 was least recently used. Let us run and check. Yes, 3 is gone. Say 3 was on the top. 3 is recently used. So when I am inserting 6, so I am exceeding the capacity 5. So 6 is removed. That 3 is removed because it was least recently accessed. That's how you can utilize this for a fixed size of 5 as a cache memory. Let us check it based on the order. I will remove this because this is for ordering, right? Ordering based on access. No, ordering based on insertion. So 1, 2, 3, 4, 5. Now even if I access 2, 5 and 1 also, nothing will happen. Who will go away? First inserted one will be gone, because 1 will be removed, that was inserted first. So 2, 3, 4, 5, 6, 1 is gone. So whether you want based on the insertion order or access order, you can remove the key if the capacity is increasing. So I have set the capacity as 5, so I directly wrote it here 5. If you want it in a proper way, then you can write your own class and do it. So once again, I'll tell you, this method will tell when to decide that we should remove the eldest entry. So if the size is greater than 5, then remove eldest entry. So when this method will be called, whenever you put that method will be called, or when you're trying to insert, that method will be called. So it will delete the eldest entry. Based on what? Based on the insertion order or based on the access order, it will remove the eldest entry. So that's all about this linked hash map. So you go through this class, just try to utilize these methods and override this method. You can write your own separate class and do it. Instead of overriding just a method here, you can write a separate class that is extending from linked hash map, and you can try a program. So that's all in this video.